Welcome to the Deep Dive, where we like to take these really complicated topics and make them a little easier to understand.
Yeah, break it down.
Exactly.
Yeah.
So today we are going to dive into the world of prediction methods.
Ooh, fun.
Yeah, it's a super crucial part of data mining.
It is very important.
It is, and I think this is going to be especially useful for those of you who are out there working with relational databases.
Yes.
Because we're really talking about unlocking the predictive power of data that you're already working with every day.
Yeah, I mean, think about it. Like, you have this massive database full of customer transactions. Basic analysis might tell you the average sale.
Right.
But what if you could use that data to predict which products are likely to be bought together?
Ooh, interesting.
That's where prediction methods come in.
Okay, so we're kind of going a step beyond just describing what happened and actually using that information to get a glimpse into the future.
Exactly. Prediction methods are all about using past data to make informed guesses about future trends.
Okay.
Think of it like spotting patterns, right?
Okay.
Data mining is the process of finding those patterns in large data sets.
Got it.
Prediction methods help us interpret those patterns to anticipate what might happen next.
So data mining is like, we found the hidden message.
Yes.
And then prediction methods are how we decode it.
Perfect analogy.
Okay, I like it.
But now, not all predictions are created equal.
Oh, interesting.
There are different types of prediction problems, each requiring a specific approach.
Okay, so what are these different types of prediction problems?
Let's start with classification.
Okay.
Imagine you're building a spam filter.
Okay, yeah.
You want to be able to classify incoming emails as either spam or not spam.
Right.
That's a classic classification problem.
Classic.
So
So based on patterns in past emails, the filter can predict whether a new email is likely to be spam.
precisely, and decision trees,
Okay.
which we'll touch upon later, are often used for this type of prediction. They work by creating a series of yes-no questions based on the characteristics of spam emails.
Gotcha. So classification is all about sorting things into categories.
Yes.
What about the other types?
Another important category is regression.
Okay.
Here, we're not sorting things into categories, but rather predicting a specific number.
Okay.
Think about trying to predict the sale price of a used car based on its mileage, age, and condition.
So instead of just saying this car will be expensive, we can use regression to try to estimate the actual price.
Exactly. One popular method for this is linear regression, where we essentially draw a line of best fit through our data to predict the relationship between the car's features and its price.
I got you. So classification is about categories.
Yes.
Regression is about specific numbers.
Numbers?
Is there a third one?
There is a third one.
What is that?
It is time series.
Time series.
So here we're dealing with data points collected over time. Think about tracking stock prices or analyzing seasonal sales trends for a business.
Okay, yeah.
The key here is to identify patterns that repeat over time.
So if we have data on energy consumption for a city over the past few years, we could use time series analysis to predict future energy demands.
You got it.
Okay, cool.
And understanding these patterns can be incredibly valuable for making informed decisions, whether it's about energy consumption, inventory management, or even predicting the spread of a disease.
So many applications.
So many.
All right, so we've got our three main categories: classification, regression, and time series.
We do.
But how do we actually make these predictions?
Yeah.
What are some of the tools that we have in our prediction toolbox?
Well, there are a whole bunch of methods out there, but let's focus on a few popular ones for now.
Okay.
We've already touched upon linear regression.
Yeah.
Which is great for predicting a number when there's a linear relationship between the variables.
So if the price of a car tends to decrease as its mileage increases, we can use linear regression to model that relationship.
Exactly.
And predict the price based on mileage.
Now, what if the relationship isn't quite so straightforward?
Okay.
What if there are multiple factors influencing the price and the relationship isn't simply a straight line?
Yeah.
That's where decision trees come in handy.
Well, right, because we were using decision trees to classify our spam.
Remember?
Yeah, so we can use those for regression problems as well.
That's right. We can use decision trees to break down a complex problem into a series of smaller, more manageable decisions.
Okay.
Think about trying to decide whether to go for a picnic based on the weather forecast, your schedule, and your mood.
Okay.
A decision tree can help you weigh different factors and arrive at a prediction.
So it's kind of like a flow chart that guides us towards a prediction based on a series of choices.
Exactly.
Interesting.
And then for really complex scenarios, we might turn to neural networks.
Okay, neural networks sound pretty intense.
They are powerful methods inspired by the way our brains work.
Wow.
capable of learning intricate patterns from massive data sets.
So when we're dealing with like extremely complex patterns and we have huge amounts of data,
Neural networks.
that's when we want to use neural networks.
Yes.
Can you give us an example of how they're used?
Imagine you're building an app that can recognize different objects in a picture.
Okay.
That's where neural networks excel.
Okay.
They can be trained on millions of images to identify patterns and then use those patterns to predict what's in a new image.
So it's almost like we're teaching the computer to see in a way.
Kind of.
Yeah. Wow, that's really cool.
It is cool.
It seems like neural networks have a lot of potential for solving these really complex prediction problems.
They do. But remember,
Yeah.
choosing the right prediction method depends entirely on the problem you're trying to solve and the data you have available.
Okay.
There's no one-size-fits-all solution.
Yeah, it's like you have all these different tools in your toolbox,
Right.
but you wouldn't use a hammer to screw in a screw.
Exactly. And that's what we'll explore further in this deep dive. We'll look at the strengths and weaknesses of different prediction methods and how to choose the right tool for the job.
Can't wait.
But for now,
Yeah.
let's pause here
Okay.
and reflect on what we've learned so far.
Welcome back to the deep dive. So we've talked about, different types of prediction problems.
Right.
But we haven't really gotten into how these prediction models are actually built.
Yeah, it's a bit like constructing a building.
Okay.
You need a solid foundation and the right tools for the job.
Makes sense.
The first step is preparing your data.
Okay.
Think of it as cleaning and organizing the building site
Okay.
before you start construction.
So if we have like a database, full of customer transactions,
Yeah.
what kind of preparation are we talking about?
We might need to handle missing values,
Okay.
like incomplete customer addresses,
Yeah.
or we might need to convert data into a format that our prediction methods can understand,
Gotcha.
like changing dates into numerical values.
Right.
This step ensures that our data is in tip-top shape before we start building our model.
Garbage in, garbage out.
Exactly.
So once the data is prepped,
Yeah.
then what?
Then comes the actual data mining.
Okay.
This is where we apply the chosen prediction method
Uh-huh.
to uncover those hidden patterns and relationships within the data.
So if we're using a neural network, this is where we train it on that prepared data.
Precisely, we feed the data into the neural network,
Okay.
and it learns from the patterns, adjusting its internal parameters to improve its predictions.
So we're teaching it to recognize the patterns
Exactly.
that will help us make accurate predictions.
But we can't just assume our model is perfect after training.
Right.
We need to put it to the test,
Yeah.
which is where evaluation comes in.
Okay. So how do we evaluate a prediction model?
It's more like checking the building's structural integrity after construction.
Gotcha.
We test the model on unseen data,
Okay.
data it hasn't encountered during training,
Uh-huh.
to see how well it generalizes.
So we want to make sure that it can accurately predict outcomes for new situations, not just the data that it already knows.
If a model only performs well on the training data,
Yeah.
it's like a building that looks great,
Right.
but collapses under the slightest pressure.
Not helpful.
Not very useful for making real-world predictions.
Well, and that makes me think about, the real world where things are constantly changing.
Yes.
So how do we ensure that our prediction models can, stay relevant and accurate over time?
That's where adaptability comes in.
Okay.
We need to make sure our models can evolve as new data becomes available, or as the underlying patterns in the data shift.
So it's not like a one-time build.
No.
It's more like a continuous process of, learning and adaptation.
Exactly. We might need to retrain our models with fresh data,
Right.
adjust the parameters, or even switch to a different prediction method altogether.
So we need to keep our models flexible
Yes.
and responsive to the, ever-changing world. I can see how that is just absolutely crucial for ensuring that our predictions are reliable and valuable.
But building these models isn't always a walk in the park.
Oh, really?
There are some unique challenges we need to be mindful of,
Okay.
especially when dealing with real-world scenarios.
Like what kind of challenges?
One common challenge is dealing with complex constraints.
Yeah.
Think about our earlier example of predicting the sale price of a used car.
Yeah.
In the real world, we might have limitations
Okay.
on the number of cars we can sell in a particular region, or the minimum price we're willing to accept.
Right. So it's not just about finding the most statistically accurate prediction.
No.
It's about finding a prediction that works in the real world,
Precisely.
taking into account all these other constraints.
And incorporating these constraints into our prediction models can get quite tricky.
Okay.
We might need to use specialized techniques
Uh-huh.
to ensure our models respect those constraints.
So constraints are a big challenge.
They are a challenge.
What else?
Another important consideration is dealing with multiple objectives.
Okay.
Often we're not just trying to optimize one thing, but several things at once.
Can you give us an example?
Think about a business trying to predict sales.
Okay.
They might want to maximize revenue,
Right.
but also minimize advertising costs.
Yeah, that makes sense.
These objectives can sometimes be in conflict with each other, making it a delicate balancing act.
Yeah, it's like we're trying to find the sweet spot where we hit all of our targets.
That's a great way to put it. It requires careful consideration
Yeah.
and often involves making trade-offs.
Okay.
We might need to prioritize some objectives over others,
Right.
or find solutions that satisfy certain thresholds for each objective.
Finding that balance is tough.
It is a challenge.
What about the dynamic nature of data itself?
Yeah.
How do we keep our models relevant when the patterns within the data are constantly shifting?
That's where the concept of concept drift comes into play. It's the idea that the relationship between variables in our data can change over time,
Okay.
making our models less accurate.
Can you give me an example?
Imagine we're building a model to predict customer churn.
Okay.
That is, which customers are likely to leave.
Right.
Our model might be very accurate initially,
Okay.
but what happens if a new competitor enters the market?
Uh-huh.
Or there's a sudden economic downturn?
Yeah. Those things could really change customer behavior.
Exactly. The patterns we were relying on might no longer be valid.
Right.
And our model needs to be able to detect and adapt to these changes.
So how do we handle concept drift?
Well, there are various techniques for dealing with concept drift.
Okay.
One approach is to retrain our models regularly with fresh data.
Okay.
Another approach is to use ensemble methods.
Ensemble methods.
Which combine multiple models
Okay.
to improve robustness.
So instead of relying on one model,
Right.
we're using a variety of models.
Think of it like having a panel of experts with different perspectives on a particular problem.
Yeah.
By combining their insights, you can create a more balanced and accurate overall prediction.
So it makes the system more resilient.
Exactly.
Okay, cool.
Ensemble methods help us create a more resilient system
Yeah.
that can handle the complexities of dynamic data and concept drift.
That makes sense.
But for now, let's take a quick pause.
Okay.
When we return, we'll wrap up our deep dive into prediction methods with some final thoughts.
Welcome back to the deep dive. So we've, covered a lot of ground in this deep dive.
We have.
Talking about, the different types of prediction problems.
Yes.
The process of building and evaluating models.
Right.
And even some of the challenges like dealing with, real world constraints and concept drift.
It's been quite a journey.
It really has.
But I think it highlights just how powerful prediction methods can be
Yeah,
for anyone working with data,
for sure.
especially those of you familiar with relational databases.
Absolutely. I think by, applying these methods,
Yeah.
we can really transform raw data into those actionable insights
Totally.
that enable us to make, more informed decisions.
Yes.
But as we kind of wrap up this deep dive, I'm curious, what is the one key takeaway
Ooh, that's a good question.
that you want our listeners to remember?
I'd say the most important thing is to remember that prediction methods are tools.
Okay.
And like any tool, they need to be used skillfully and thoughtfully,
Right.
understanding the different types of prediction problems,
Yeah.
the strengths and weaknesses of various methods, and the potential pitfalls to watch out for is crucial.
So it's not just about blindly applying algorithms.
No.
It's about understanding the nuances.
Yes.
And really using these methods strategically to solve, real world problems.
Exactly. And as you continue working with data
Yeah.
and exploring the world of prediction methods, always remember to stay curious, keep learning, and never stop questioning.
I love that. Well said. It's been such an amazing time exploring this really fascinating field with you.
It has.
I really hope that our listeners out there have gained a deeper appreciation for, just the power and potential of prediction methods.
I hope so too.
And remember, whether you're, analyzing customer data, predicting market trends, or even forecasting inventory needs, the insights that you can gain from prediction methods can be so incredibly valuable.
They really can.
Well, that is a perfect note to end on. Thank you so much for joining us on this deep dive into prediction methods.
Thanks for having me.
And to all of our listeners, thank you for tuning into the deep dive. Be sure to like, share, and subscribe, and we'll see you next time.